Hi everyone. Today in this lecture I want to talk about another program control instruction, which is jump and label instructions. Jump and label instruction are a set of instructions that they work together, and together they can control a zone of instructions, so they can change or alter the sequence of program execution, so the rung of the program won't be executed one after another one. What you can see here is different rung of the program, and let's assume that somewhere, for example here, we have a jump instruction. We are going to talk about how jump instruction works, but let's assume that the jump instruction is active. If the jump instruction is active, it will look for a destination, so it will jump into a destination. So it will be active here, so the program will be executed from the beginning, and when it reaches to a jump, which is active, then it will skip execution of the remaining program until it reaches to the jump destination, and from jump destination it will continue executing the program. So in a program like this, the portion that is shown here will not be executed. The jump instruction is an output instruction. Here you can see how instruction looks like in the program. So it is something like this: JMP. JMP refers to jump instruction, which is an output instruction. And remember that the jump instruction always need to have a destination. The destination is called label, so the jump instruction always need to have a label. The label, which is shown by LBL, is an input instruction. So these two together, they allow this a scan sequence to be changed and altered. They are also known as a skip and go to instruction. Now you should know that the jump can be used as conditional output. So it is an output and it can be conditional. But the label instruction, which is an input instruction, is always true. And it makes sense because label is showing the destination. You don't need any true or false. The destination is always your destination. But the jump can be executed or it can be ignored. So you, based on the condition you have for your jump instruction, then the program decide if the scanner needs to jump to this destination or it needs to continue scanning the program in the ordinary sequence. Together, jump and label, they can reduce the PLC scan time by jumping over unnecessary instructions. So they can jump or basically step over a group of rungs to the label rung, and the label identifies the destination rung for the jump instruction. Now something that you should remember is that they both need to have a reference number. So both your jump and label, they need to have reference number. Or in another word, I would say they need to have an address. So now the question is that what is the format for the address? So the format that you need to provide for the address of jump and label is in this form. The address is Q2 colon, and then you have to provide a number from 0 to 255. So this is the address that you need to write on top of your jump or label instruction. Let's say this is a reference number, not an address. So this reference number basically helps the jump and label in the program to know which label is related to which jump instruction. So when the scanner is executing the program is reading the program and executing the program, and it will reach us to a particular jump instruction, for example, what we have here, then according to the reference number, it can find the destination. So there might be more than one destination, and the destination related to this particular jump instruction has the exact same reference number. For example, they are both Q2:30. So whenever this jump is active, then the program will look for a destination with the same reference number, and let's assume that the scanner finds the label, which is the jump destination, with this same reference number somewhere here, so it will jump to this particular destination. The reason that we have this reference number is the fact that we can have more than one jump and label instruction in our program. So as long as we have reference number for them, then the program knows which destination is related to each individual jump instruction. Now, something that you should remember is that every jump needs to have a destination. So in your program, you're not allowed to have two label instructions with the exact same address or reference number. So let's assume that you have another, so here is one label. So here we have a label or LBL with a reference number as Q2:30, and let's assume that I have another label somewhere here with the same reference number as Q2:30. Now what will happen is that when the program reaches to this jump and the jump is active, then the scanner should look for a label with the same reference number. Now the problem is that the scanner can find two labels with the exact same reference number, so it will be confused that which label is the correct one and which one should be the jump destination. So this is a wrong situation. So you are not allowed, so I'm going to write it here, that you are not allowed to have label with same reference address or reference number. So the label cannot have same reference address, but jump is allowed to have same reference number. So let's go back to the program and see what happens if we have more than one jump with same reference number. So this time, let's assume that I have another jump instruction somewhere here, for example, with an address of Q2:30. So if the program reaches here and the jump is active, then it will look for the label with the same address or same reference number. So it will jump to this particular rung. Now, let's assume that this is not active. So then the program will continue executing until it reaches to the next jump, and if this jump is active, then it will look for the label with this particular address or reference number, so then it will jump to this label. So you can have multiple jump with the same reference number because it doesn't make any confusion in the program, as long as there is one single and unique label instruction in your program for that particular reference number. Then there would be no confusion in that scenario. Now, something else that you should remember, that label instruction always comes at the beginning of the rung. So even though it is an input, but it's not an input that you can decide to put it anywhere in your rung. So the label should always be the very first instruction of the rung, and it is always true. So you should not be worried about the condition of this rung. So basically, the label is there not to decide about the condition of the rung because it is always true. It is there only to show the program scanner where is the destination of the related jump instruction. Now let's take a look at this particular program that I have here. This program, let's assume that terminal 1 of our input module is true. Then we have continuity over this instruction. So it means that the jump instruction will be active. So the jump will be active. Wrong 1 will be executed. Because the jump is active, and you can see that this jump is an output instruction, it has a reference number on top of it, which is Q2:50. The program will look for a label, which is supposed to be the very first instruction at the beginning of the wrong, with the same reference number. So here, this is not a label, this is not a label, this is not a label, same here, same here. This is the label instruction at the beginning of the wrong, which has the exact same reference number. So the program will skip executing wrong 1, 2, 3, 4, 5, and it will execute wrong 6. And it will continue from here. So if I ask you which wrong of this program will be executed, if terminal 1 is active or true, your jump is active basically, then you have to tell me that wrong 0 will be executed, and then after that wrong 6 will be executed. So this is the sequence of the wrongs in this program if the input is true. Now let's assume that it is not true. So in the scenario that we don't have this as true, so if we don't have continuity over here, then what will happen is that the jump won't be active. So the program will be executed normally and all the wrong will be executed from 0 to 6. And when it reaches to wrong 6, it basically ignores this label because the label is always true. So the output of 03/4 will be true if the input 7 is true. So it doesn't matter what's going on, the label is always true. Now, there are something that you should be very careful about when you're working with jump and label instruction. The first one is a backward jump. What is a backward jump? We have two different ways of using jump and label instruction. You can use jump and label instruction in this way. Let's assume that you have an input which is controlling your jump, JMP, with a reference number, for example, equal to Q2:100. And then we have some program wrong, and then the next wrong that I want to demonstrate is the label. So LBL with an address equal to Q2:100, and then another input instruction which is controlling a particular output instruction. This is what we call as a forward jump. So I'm going to write the name here. This is a forward jump. A forward jump basically skip part of program. So it is not going to be a problem if you use a lot of forward jump, because forward jump will reduce the scan time and it makes the program quicker because it avoids the execution of some of the wrongs that are not required to be executed for a particular scenario. So this is what we call as forward jump, and it's not something that you should be very careful about as long as your application sequence is being implemented correctly. But the next one that you should be very careful about is backward jump. So in this scenario, let's assume that you have a label, which we know it's always true. So it doesn't hurt to have a label at the beginning of a wrong. So let's assume that the address is Q2:50. And then we have an input instruction which is controlling one of our outputs, and then later, after some wrong, we have another one which is being controlled by an input, and the output is a jump instruction with the same address as Q2:50. Now this time what will happen is that instead of skipping part of program, here we are going backwards. So the program will start executing this wrong from here. Everything will be executed up to here. Now if the jump is active, it will go back here to this destination. So this part of program will be repeated, while in forward jump this part of program was ignored and we skipped this part of program. So what we call this way of using the jump and label instruction is backward jump, which basically repeat part of our program. So this is the one that you need to be very careful about, because it can increase the time of your scan cycle. And if it increases the scan cycle, what will happen is that it can keep the program to remain in a loop for too long, and consequently it can trigger a watchdog timer fault. So that's why you need to be careful about. The next thing is that remember that your label is always the first instruction. We already talked about this one. And the next one that is important to mention here is that you're not supposed to use a jump instruction into an MCR zone. Let's assume that these are MCR wrongs. So the MCR is supposed to control this portion of what we have in the middle. So the execution of these groups of instructions are related to the situation or condition of your MCR. So MCR decide if this group is supposed to be executed or if the execution should be ignored. Now, if you have a jump and you put your label within this fence, so a scenario similar to this. So let's assume that your jump is somewhere here and your label is here. What will happen is that basically if your jump is active, then you're telling your program to jump here to this point and execute the program after this label. So with your jump, you're deciding that half of, not necessarily half, but part of this group needs to be executed and part of them should not be executed. And that's completely opposite of what MCR is doing. So MCR is deciding if all of them should be executed or part of them should be executed. So remember that you should not jump into an MCR, but you can have two MCR or a pair of MCR between your jump and label. So if your jump is here and your label is here, it is absolutely okay to use an MCR in the middle like this. So this is something that the program is okay with, but this is a wrong situation. Okay, now let's talk about the differences and similarities between jump and MCR. So we want to compare jump instruction versus MCR instruction. So there are some similarities and definitely there are a lot of differences. The similarity is that they both force the PLC scanner to skip over a block of PLC ladder logic. And regarding the differences, obviously there are a lot of differences, but the main two differences that you should be completely aware of is that, first, the jump can also repeat a block of wrongs. So not only it can jump over a block of wrongs, it can also repeat a portion of it. And the second one that is very important here is how they affect the situation or the condition of the output. If you have an MCR, the MCR will set all non-retentive output to 0. So basically, the MCR will force all non-retentive output to 0 if the MCR is not being executed. So if your MCR is not activated, then it won't let the program to read this part of program. And what happened is that all the non-retentive output within this fence will be set to 0. And if there is any retentive one, the retentive will keep its value. But in jump instruction, the program won't force the output, the non-retentive output to 0, and the output can keep their last condition. Their condition won't be updated because the program is not being executed at those specific rungs, but they can keep their the latest value. So with jump, regarding non-retentive output, they can keep the latest condition. So these are something that you should be completely aware of. You should know what happens to the condition of your non-retentive output if you are using an MCR or if you're using a jump. So jump basically won't affect any of your output, and the output will keep their final values and they won't be updated. That's the only difference between being executed or not being executed. But MCR will force all of them to 0. So even if the value is 1, now because the MCR is not active, the output will be forced to 0 if the output is non-retentive. Remember that we are not talking about retentive, because retentive memory can keep their value and they need to be reset in order to go to 0. So they need the reset function, and it doesn't matter if it's a jump, if you're using a jump or MCR, they are not going to be affected by these two instructions.